Kilgore loves this because robotics and reasons. All right. So in the very beginning, guys, we're just gonna. You don't have a button that for cotangent, secant, and cosecant. These are the reciprocal buttons. But remember that cotangents are reciprocal of tangent. So this is equivalent to 1 over tan of 38 degrees. And I'm going to show you two different ways to get that number. So in your calculator, so here's your calculator. Make sure your mode is in degree mode. So let me show you how to get to degree mode first. Come on, buddy. Okay, let me reset mine. All right, so click on mode. The mode is right next to that second button. And you should see something right there that says radian or degree. So sometimes you also get a gradient, but we're just worried about those two. So go to degree, push enter. So we're going to be working with degree mode because I think you guys find degree to be easier. And then there it is. I'm going to go second quit to get out of there. And now in the upper right hand corner, if you have a colored one, it should say degree. If you have the black and white ones, you won't get this top marker here. All right. So how do I get cotangent of 38 degrees? Like this. You just go 1 divided by tan, 38 degrees. I'll show you another way. And here it is, 1.2799. At least 3 digits after the decimal. The more, the merrier. 1.2799. You could also get it. There's a button that's called the reciprocal button. It's this one right here. So you can push tan 38 and then close it. And then do you see this button right here next to the sign that says x to the negative 1? That's called the reciprocal button. You push it and then you push enter. Don't get that confused with inverse. It is not. It's just reciprocal. You push enter and there it is. It just reverses it 1 over whatever. Do you guys see what we did? Okay, so there you go. So hopefully now we're going to get really fast. So cotangent 140, you can go 1 over tan of 140 degrees. Unless you have a CAS, and you might have the COT button. So here we go. I'm going to go 1 divided by tan of 140. And voila. Are we shocked that it's negative? Hopefully we're not shocked that it's negative because in 140 degrees, tangent is y divided by x. And the y is positive and the x is negative. Well, cotangent is x divided by y, but same deal. See, so positive divided by negative or negative divided by positive is a negative. All right, so here we go. What was that number? Negative 1.19175. Negative 1. I already forgot it, short-term memory. 19175. 19175. Secant, the reciprocal of which one? Cosine? Is cosine of 238, is cosine positive or negative at 238 degrees? 238 degrees is what quadrant? Yeah, it's negative because it's in quadrant 3. So we know it's going to be a negative answer. So we're going to go 1 divided by cosine of 238. And voila, negative 1.887. Negative 1.887. Secant to 53, that's going to be positive because everything in quadrant 1 is positive. So this is going to be 1 over cosine of 53 degrees. So let's see what that is. I'm just going to push cosine 53 and push the reciprocal button. It should be the same. 1.6616. 1.6616. Cosecant negative 179. So 1 divided by sine of negative 179. Negative 57.2986. Negative 57.2986. Or 87 if you round. And cosecant 180. Well, that's 1 over sine 180. And sine 180 degrees is 0, so this is undefined. If you try to put that in the calculator, it's going to tell you error, guys. If you try to do 1 divided by sine 180 or negative 180, I don't remember which one it was. See? Error. Oh, 180. Cool or not cool? Okay. Sinusoidal waves. Before we start, Sinusoidal waves are a part of your lives, whether you know it or not. Every time you use that cell phone, it's a wave. Every time you pop popcorn in the microwave, look, it's a microwave. It's a wave. Every time, look, this light that we're being bombarded by, it's a wave, light wave. The electricity that's that's powering this building, it's AC power, that's a wave. When you push lock and unlock on your key fob, if you have an oscilloscope, that would measure a wave because it's just a frequency. Waves are a part of your everyday life. What you're using right now for vision, there's light going into that eye of yours, and it's a wave that's going in. If you were in space, the sound, if you were to, is there sound in space? No, there's no sound. You know why there's no sound? Because it's a vacuum. You need air for these waves to travel. And in space, it's a vacuum, so nothing can travel. Well, light can travel, light waves, but sound can't travel. Cool, right? Or you guys don't think that's cool? So if you scream in space, well, you can't even scream, right? Because you can't breathe. But I guess if you put a help, I guess like if you're in a suit, you could talk, and while you're inside, you can hear it. But it's outside of your suit, you won't be able to hear anything. There's nothing. There's no. You know what I mean? All right. So here are some property of waves. I'm gonna draw a wave. Try and draw a wave, guys. All right, guys, focus. Try and draw a wave. Doesn't have to be perfect. Try to make it symmetrical. And then try to cut it right down the middle. All right, what should we talk about first? Have you heard of the word convex or not convex? Concave, concave up, concave down? Okay. This is concave down right here. This is concave up. It's like an upside down bowl or a bowl facing upwards and an upside down bowl. And then between those 2 points, you have a point, and that is called a point of inflection. Point of inflection. And you guessed it. What's a point of inflection? Where concavity changes. Point where concavity changes. Does that sound familiar to you guys? Concave up, concave down? No? Okay. So if it doesn't, a parabola opening upwards is concave up. A parabola opening downwards is concave down. That's all it means. Nothing crazy. Let's see what else. I have something called a max on a wave and a min on a wave, assuming it's a typical sinusoidal curve. Because there is something like a sinusoid that increases in amplitude and a sinusoid that decreases in amplitude as time continues. But we're gonna say this is max and this is min. And what do you think they call the mid? Oh, I already said it. The line in the middle, this blue line, is called a midline or a sinusoidal axis. Sinusoidal axis. Let's see what else. The gap between the max and the midline is called an amplitude. Have you guys seen this before? The Galileo has in physics. And Rodriguez, you took physics last year, right? I know there's a junior that took physics as a sophomore. Okay, Annabelle. Also, the gap between the midline and the minimum is also an amplitude. Let's see, what else? What else? Oh, yeah. How can I forget? From peak to peak, it does not have to be peak to peak. This is called a period. The period just means A period just means how what's the length for it to repeat. You can also call this the period. This is also one cycle. I'm gonna say 100% of a cycle. Why did I do 100% of a cycle there? Because I'm gonna break this up into quarter length. You see this right here in purple? That's 25% of a cycle. See? If you call this a whole period, guys, don't worry, I'll go over there in a little bit. If you call this a whole period, this is broken up. That's 25% from the midline to the minimum. That's another 25%. From the minimum to the midline again, that's another 25%. From this guy to here, that's another 25%. Look, from there to there, that's 100% of a cycle. Does that make sense? That makes sense, Travis? I'll show you guys here. See how from the max to the midline, that's 25% of a cycle. And then from the midline to the minimum, that's another 25%. From the minimum to the midline, that's another 25%. And from here to here, that's another 25%. If I count from peak to peak of one cycle. What is what? Point of inflection. Point where something changes. What is what? Amplitude just means it's like a vertical stretch. So it's just the distance from the maximum to the midline. You're going to see more about it right now in a little bit. All right, guys. I think we got everything. I think. Yeah, when you multiply, the amplitude is just like, well, you'll see right now. We'll do because we're going to do the parent function sine and cosine, and then we'll talk about it. So remind me as soon as I draw the sine and cosine, ask me that question. We ready, guys? I know it's hard to have math class last period. All right, we're just going down the alphabet. Y equals a cosine, open parenthesis, b, open parenthesis, x minus c, close, plus d. Or y equals a sine, open parenthesis, b, open parenthesis, x minus c, close, plus d. Relax. The A stands for amplitude. It kind of works the same way as when you're multiplying a function that does either a vertical stretch or compression. This D here on the outside moves your sinusoid either up or down, so vertical shift. This C here moves your sinusoid either left or right, so a horizontal shift. In the math world, they call this a phase shift. I think I put it in here. Phase displacement. And then the B, not directly, tells you horizontal dilation. And we might have to do a quick lesson on that. Maybe next time we meet, we'll do that really fast. Okay, nothing crazy. I tell you details here, guys. A is the amplitude. Technically, is the vertical dilation. If negative, reflect from parent function of the x-axis. Well, horizontal dilation, that's what you get. C is phase displacement. D is the location of the sinusoidal axis. Okay, you guys ready? And then, of course, here it says period is 360 divided by B, because the period of a unit circle is 360 degrees, like one revolution is 360. One revolution in radians is 2 pi. So from that, you can tell you that B is 360 divided by period, if in degrees, or 2 pi divided by period, if in radians. Radians? Degrees. All right, how does sine and cosine, how are we going to get these graphs from the unit circle? I guess we could do a quick Google if you wanted to, but yeah, let's do that really fast. So just observe. I'm just going to do a Google. We'll find it. Or you know what? Let me go to YouTube. YouTube. What did I put? Graphing sine or graphing cosine from unit circle. Graphing cosine from unit circle. And I want a short one, 23 seconds. I like this one. This video out. Okay, check it out. Look, it's graphing cosine. You're about to do that right now. But don't worry, we're going to make it easy. See, it's just graphing. And look, you get a nice sinusoid. You don't think that was cool? Yeah, that was really cool. How long is this video? 8 minutes? No, too long. Okay, that's exactly what we're doing. Hello, Arctic Fox. Let's do the cosine graph first, because that's what we're going to focus on today. So I am going to, and don't worry, guys, you don't have to be perfect. So let's draw like a y-axis and then an x-axis right down the middle like that. And then the highest it's going to be, cosine is going to be is 1. So I'm going to put a 1. I'm going to go, and I'm going to go the same distance down. I'm going to call this -1. We're going to go in degrees. I'm going to call this 0 degrees. I'm going to go a little distance. I'm going to call this 90 degrees. And then try and go the same gap. I'm just looking at 90, 180 here. And then 270. And then 360. Are we okay so far? Check it out. You guys just finished doing the unit circle, but now we're in degrees. What is cosine of 0 degrees? Is it 0 or is it 1? 1. Go to 0, put a point at 1. What is cosine of 90 degrees? 0. Go to 90 degrees and put a point at 0. 90, 0. What is cosine of 180 degrees? -1, so go to 180 with a point at -1. I know right now it looks linear, but don't worry. Look, what is cosine of 270 degrees? 0. Point. What is cosine of 360 degrees? 1. And I guess to make it more uniform, I'm going to go to -90 here. Cosine of -90 is 0. Okay. We're going to go slow. Wherever you have a max, write like a parabola opening downward or upside down bowl. Wherever you have a min, write a bowl like this, or draw a bowl. So make it kind of aim towards your points of inflection, towards the midline. Not my best work, but I guess it'll work. And then connect it towards the midline, towards the x-axis, but make sure that the x-axis is like a point of inflection. Try to make it look like it changes from concave down to concave up and vice versa. And then look, you just did your first sinusoid. Wasn't that cool? Yay, look at you winning at life. All right, let's do the sine one. I'm gonna move the x-axis a little bit so it doesn't look like it's continued to this one. So I'm gonna move it like right there. I'm gonna make it a little smaller. All right, let's see. I'm gonna call -90 right here. I'm gonna call 0 right there. So let me see that gap. I'm gonna call this 90 degrees. I'm gonna call this 180 degrees. I'm gonna call this 270 degrees. I'm gonna call this 360 degrees. I'm making it a little smaller. That's fine. This is 1. And this is -1. What's sine of 0? Yeah, what is it? Yeah, 0. Say it loud and proud. 0. Settle. I don't know why I said it like that. But what's sine of 90? Sine of 90 degrees. 1. Go to 90, put a point at 1. What's sine of 180? 0. So go to 180, put a point at 0. What's sine of 270? -1. Come on, guys. There's more than one of you. What is sine of 360? 0. And one more. Sine of -90. That's like sine of 270. So -1. Do you guys see those dots? All right. If you had a maximum, make it go like an upside down bowl. Aim towards the points of inflection. If you're at a minimum, make it like a kind of like a parabola or a bowl. And something like that. It's not the best, but that's fine. What do you guys think? Are you not entertained? Yeah, you guys are future engineers. You're learning. You're going to be doing waves all your life, analyzing all types of curves. Enough for reals. You know, like, okay, I'll show you a video later. We don't know enough yet. All right. Maybe in the next class session, we'll at least have enough background to do a little bit of it. All right, here we go, guys. We're going to focus on the cosine function. Why are we so focused on the cosine function? Because cosine has a peak right on the y-axis. So it's really easy to make this move left or right because I know that the maximum is right on the y-axis. It starts at, do you guys see what I mean? No? Okay. See how this maximum, look, it's right on the y-axis. So I'm just going to move the peak wherever I see fit. Chop, what do you mean? Let's do example 1 together. Suppose that a sinusoid has a period of 12 degrees per cycle. So that's my period. Amplitude is 7 units. Oh, so there's that amplitude word again. All right. Okay, let me continue. Phase displacement -4 with respect to the parent cosine function and the sinusoidal axis 5 units below the x-axis. Sketch this graph. Okay, here we go. You guys ready? So let's do a grid. So here's my grid. That's the y-axis. And since most of this is below the x-axis, I'm going to make it look like this. That's the x-axis. Let me write it over here like that. All right, let's see. Where's my midline? My midline, it says right here, 5 units below the x-axis. So I'm going to say that this is -5 right here. -5. The amplitude is 7. So that means from the midline, I'm going to go 7 up and 7 down. So from -5, if I go 7 up, 7 up, I'm going to be at 2. So there it is at 2, just a little bit above the x-axis. And I'm going to go 7 down. 7, what's that, -12? Are we doing okay so far? Okay. And okay, okay. After the fact, we'll talk about that. Remind me after this about what amplitude. All right. So where am I going to put my very first point? Well, if I'm using cosine, I should have put it right on the y-axis, but they told me my phase displacement is -4. So I'm going to go 4 degrees to the left, and I'm going to put that first. So I'm going to say that 4 degrees to the left is like right here. 4 degrees to the left, and here's my max point. Matter of fact, let me do the grid on black here. All right. Now remember, the period is 12, so that means every 12 degrees I better have a max. So I'm going to go 4, and then another 4, and then another 4. Because 4 plus 4 plus 4 is 12, right? So I'm going to be like right here. Doesn't have to be perfect. That's 8 points. Does everyone know how I got the 8? Yeah, -4 plus 12 is 8. I'm just going every 12. Now I'm going to go another 12 from the 8 to make sure that the gaps are more or less symmetric. So what's 12 plus 8? 20. So I'm going to be somewhere like right there. And these are all degrees, so put degree symbols on them. 20. At 20, put a point at the max, too. Now I'm going to add 12 to that. Where's that going to be at? 32. So go to 32. 32 is going to be like right here. And I think I can fit one more. 32 plus 12? 44. Okay, are we still okay, guys? All right, in between your max and min, in between your two maxes, you have a min. Does that make sense to you guys? Yeah, because it's symmetrical. So, in the middle of 8 and 20, or add 6 to the 8, or subtract 6 from the 20, it doesn't matter. At 14, so I'm going to say 14 is like right smack right there. You have a min point. See? In the middle between -4 and 8. So what's that? Like 2? At 2, something like right there, you have a min. Notice the difference between 2 and 14 is 12. So if I go another 12 from 14, I have another min, like right there. That's like 26. Do you guys see how I'm doing it, guys? At 38, somewhere like right there. I know, it's late. All right, are we okay so far, guys? Okay, so catch up to here. Does everyone have their max and mins? In the middle between the max and the min is a point of inflection. So right smack in the middle. So look, check it out. You see between 8 and 14, I have a max and I have a min. Look, let me get my laser. Look, I have a max at 8 and a min at 14. Right smack in the middle between 8 and 14, I have a point of inflection. So right smack in the middle between 8 and 14, add 3 to the 8 or subtract 3 from the 14. It doesn't matter. 8, 9, 10, 11. So I'm going to say 11 is like right there. And then put a point, 11, boom, right there. See? Every 6, you're going to have a point of inflection. So let's see, between 2 and 8, like at 5, like right there. I'll just put the first ones here. Between -4 and 2, so like at -1. -1's like right here. Point. Doesn't have to be perfect. And I'm just gonna wing the rest. I'm not gonna try to be perfect here, guys. You should have a lot of points of inflections. Are we still okay, guys? All right. Wherever you have maximums, upside down bowls. Wherever you have minimums, bowls or parabolas, make them aim towards your points of inflection. Make them aim towards your points of inflection. All right, connect them. We're not looking for perfection, just more or less. Yeah, that's not bad. That's not bad. How do you feel? You feel okay? Okay. Remember, Herrera, how you asked me what's amplitude? Your sinusoid needs to have an out, like it starts with a max of 1 and a min of 1, but remember we said it kind of acts like a vertical stretch or compress. If they told you that the amplitude is 7, what's 1 times 7? 7. So from the midline to the top, it did a stretch. If I didn't have if my sinusoidal axis was on -5, if my sinusoidal axis was in the x-axis, I would have gone up 7 and down 7. Well, I did go up 7 and down 7. But see how that gap is now 7 instead of 1? Because it's like it acts like a vertical stretch. If it would have been 0.5, I would have compressed. You know what I mean? Okay. All right, guys. Find the equation that you sketched. So here we go. I did cosine. So y equals a cosine, open parenthesis b, open parenthesis x minus c, close, plus d. What was my amplitude? 7. I guess we'll worry about the b in a little bit. What was my c? What was my shift? I was on the y-axis, but I went all the way, I went 4 to the left. So my c is -4. Or I guess you can say 4, but minus a negative. No, say -4. The midline, the d, -5. Are you guys following me with me, guys, or not? Okay. The b. So how do I get the b? Well, according to this, 360 divided by the period. So I'm going to go here. I'm going to go 360 divided by the period was 12. 12 goes into 36 3 times. 12, 24, 36. So this must be 30. So what's my equation? Y equals 7 cosine, open parenthesis, 30, open parenthesis, x minus a -4. So that turns to a plus -5. Is this making sense, guys? I know, guys. I know it's late. Last period is probably the worst time to have. Oh no, the worst time is probably after lunch, but it is the second worst time. All right, go to the next page. Oh, actually, no, not yet. I want to verify this. I want to use my calculator. Does everyone have your calculator? All right, take your calculator out. On the upper left-hand side, you see a button that says y equals? Push that button. When you push that button, you're going to get all these y's. Just type in this expression, 7 cosine. So I'm going to go 7 cosine. It automatically opens up a parenthesis for you. 30. Open up another parenthesis. The x is right next to the alpha. X, see? Minus a -4, so you're going to be +4. And then close it twice. Close, because you're going to close the x plus 4, and then you're going to close it to put that 30 in there. And on the outside, minus, the minus is next to the 6, -5. Do that. Don't push graph yet. All right, you want the window to look like this window. So click on, you see where it says window? It's the second from the y equals, click window. My x min, well, the smallest x I have here is -4, so I'm going to go a little bit to the left of that, so like -5 or -6. So -6, the negative is next to the enter. X max, well, the biggest it goes to is 44, so maybe go a little bit bigger than that, so like 49, 48, 49. X scale, go by like 5. X min, well, the smallest y value is -12, so go a little bit below that, like -15. -15. X max, the biggest y value I have is 2, so go a little bit above that, so like 5. X scale by 1, yeah, that's fine. Push graph. Mine's going to graph it really fast because it's a computer. Yours is going to take a little while, but you'll still get this. Okay, about the window or the white? Oh, that's scale. So y scale, I just left it alone at 1. Because I wanted it to look like this. Between negative, see, look, my x value, the smallest is x -4, so I went to the left of that. My biggest is 44, so I went a little bit to the right of that. See, make it look like that, guys. So here's my window. And then when you push graph, you get that graph. If you want to see a better one, you're like, I want to see the midline. Like, okay, -5 on y2, and now you can see your midline. You don't need to put the midline on your y2. You're fine without it. What are you talking about? Does it look like this? Don't mess with the X resolution. Don't mess with the delta x, and don't mess with the trace step. All right, check it out, guys. From your graph, I want to verify these points. So I want to verify -4, -1, 2, and 5, and 8. So you just got to push it once, push the trace button, trace, and then go -4, enter. And sure enough, at -4, my y value is 2. That's what it was. That's my max. You don't have to push trace again. I can just go -1, enter. And check it out. At -1, I am at my midline, -5. At 2, wait, was that at 2? Yeah, at 2, I better be at the lowest. So I'm going to push 2, and I'm going to push enter. And voila, I'm at the lowest, -12. So then let's see, what's the next one? The next one is 5. So I'm going to push 5, and I better be at the midline. Yep, -5. And I'm going to check one more. I'm going to type in 8, enter. Yep, I'm at the tallest. Do you see how we're doing it, guys? Don't worry, we're going to get another chance. So if you didn't get it this time, we're going to get another chance. I'm recording this too, guys, so you can always go home and practice. All right, here we go. Look at this example. It says for the sinusoid below, give the period, frequency, amplitude, phase displacement, and sinusoidal axis location. Write a particular equation for the sinusoid. Okay, so we're going backwards. We're using cosine right now, so y equals a cosine, open parenthesis, b, open parenthesis, x minus c, close, plus d. I'm just going down the alphabet. A, B, C, D. Relax. Some textbooks, especially university textbooks, like to write bx minus c. It's the same thing. Factor out the b, not a big deal. They might write it as c over b or something. Okay. Are we okay so far? All right. I think the easiest thing to figure out is the midline. 10, 20, 30, 40, 50. Okay. How do you find the middle of anything? Add, divide by 2, right? That's how you find the middle of anything. So if I want to find the midline, the biggest here, so I'm going to write d equals, add the max, 56, the y value, plus add the min, the -38, and whatever that is, divided by 2. And that's going to be your midline. So 56 plus 38, 48, 58, so 18 divided by 2, 9. Yeah, you can use your calculator, not a big deal. You can go 56 plus -38, enter, divided by 2. You can do that. Be careful though. Don't try really hard not to do, or I guess use parentheses. 56 plus -38, close, divided by 2. Use parentheses. See? Because if you don't use parentheses, if you do this, why is that wrong? Because the calculator thinks you're just doing 38 divided by 2. So look, that's not going to give you 9. See? So make sure you know, guys, how to use this. Or I guess to never make a mistake, use a little fraction feature. See, you'll never make a mistake if you use this. How did I get the fraction feature? Alpha y equals enter. And you get the little fraction feature. All right. There it is. So 9 is probably like right there. Not quite at that line because it's going by 10, 10, 20, 30, 40, 50. 10, 20, 30, 40, 50, yeah. The next thing that I think is easiest to figure out is the amplitude. The amplitude is the distance from the peak to the midline or from the midline to the minimum. It does not matter. So I'm going to go 56 minus 9, so that's 47. Or you could have done 9 minus a -38, and again, that's 47. See? Do you guys see how we're doing it, guys? All right. Next, the C. Well, I should have been right on the y-axis, but it's not. How many am I away from the y-axis? What's that number? 3. So the C is 3. 3 to the right. And then last, the B. The B, I get it from finding the period. The period, well, let's see, peak to peak. I have a peak at 3. I have a peak at 23. So just go 23 minus 3. Or I guess if you see it, you can just write 20. 20 degrees is the period. It also wanted the frequency. The frequency is just the reciprocal of your period. So it's not all that. Frequency 1 over 20. If times in seconds, then it's a hertz. Okay, what's the period? What's the beat? 360 divided by 20. 2 goes into 36. Is that 18? So there it is. 18. Do you guys see how we did it? All right, here's my equation, guys. Y equals 47 cosine, open parenthesis, 18, open parenthesis again, x minus 3 to the right, there it is, plus 9. Okay, we get another opportunity to practice, guys. Type that into your Y1. Take your calculator, click on Y equals, clear it. You can just push clear. And we're just going to type it in. We're going to go 47 cosine. 47 cosine. It opens up a parenthesis for you. 18. Open up another one. X minus, I already forgot, was it 3? Close, close. Plus 9. Don't push graph yet. If you want to see the midline on Y2, you can put 9. If you want to. You don't have to. Click on window. What's your smallest x here? -1, -2, -3. -3. I just counted. So maybe -3 or -4. I guess you could have left it as -6. What's your biggest x? Well, 23, 24, 25, 26, 27. So 27 or 30. See, you just want to see them. X scale by 1, that's fine. Y min. What's the smallest y value? -38. So maybe go like to -40 or -42. So you can see it. -42. Y max. What's the biggest y value? I go to 56. So maybe go like to 60 or 61 or 62. 62. Y scale. This one I am going to change it. I'm going to go by 10 because they go by 10. 10, 20, 30, 40, 50. So I'm going to go by 10. Y scale, 10. Don't worry about the resolution. Don't worry about delta x. Don't worry about trace step. Push graph. See? Did yours come out like that? Yeah. I'm going to go back to window or to y equals. I know what you're thinking. Maybe you're tired and you're not thinking anything, but maybe you're thinking, when am I ever going to do this in real life? Guys, you guys are the future doctors. Who do you think is going to calibrate those machines? You are. You're going to be doing these exact procedures. Maybe not exactly this, but you're going to be calibrating it. You want to see a heartbeat. You got to calibrate it. Where are you going to, from what to what? Maybe you're going to be an engineer. You're going to be messing with an oscilloscope. You got to figure out, like, how big is your spacing? How much, you got to figure all these things out. So this is the same thing with this, guys. It's just a tool. So embrace it. Start messing around with it. All right. Here it is, graph. I'm going to push a trace button. And I'm just going to check. What am I going to check? I'm going to check these three. 3, 13, and 23. I better get those y values. So I'm going to push trace 3. So did I already push trace? Yeah. 3, enter. Yep, it says 56. See? I'm going to see if at 13 it gives me -38. So I just push -13. Bam. Oh. It was at what again? At 13, not -13. Why did I put negative? Delete, enter. There it is, -38. What's the next one? 23. Put 23, enter. There it is. It works. How are we feeling? Hey, demerit. No yawning. Okay. Are you feeling okay, guys? All right. Last one. I think it's the last one. Yeah. Last one, guys, and then we're done. Is this torture? Is this torture, guys? Oh, are you not entertained? Don't judge. They're all good. No, don't judge them. All right, here we go. The figure below shows a quarter cycle of a sinusoid. What does that mean? What does a quarter cycle mean? 25%. Write a particular equation and check it by plotting it on your graphing calculator. Okay, guys, if this is 25%, that means this 8 is your midline. It has to. 25%, that's your midline, and then that 3 has to be a minimum. So the difference between 8 and 3 is 5, so that means 5 is your amplitude. So I'm going to go up 5. What's 8 plus 5? So at 13, I'm going to say that this is 13. See? This gap between 17 and 24, that's a 7-degree gap. I think it's 7 degrees. Yeah, it is. So if I go back another 7 degrees from the midline to a max, so it looks like right here at 10 degrees. So I'm going to put a point at 10 degrees, 13. Does everyone know why I put a point at 10, 13? Because this is a quarter of a cycle. Every quarter, you're either going from high to middle, middle to low, low to mid, mid to high. That's how it goes. So here it is. Here's that one so far. So we got that. I'm going to go another 7 from the 24. So what's 24 plus 7? So at 31, I'm going to go back to the middle. Bam. I'm going to go another 7 from the 31. What's that? 38. And I think that should be enough for a complete cycle. Yeah, that's enough for a complete cycle. I'm doing cosine. We can do sine, but right now we're focused on cosine. Don't worry, we'll talk about cosine next time. We'll talk about sine next time, sorry. I already know what, let's see, what do we know? What's the easiest one? A? Okay. A is the distance from the 13 to the midline or from the 8 to the lowest, which is 5. B, we'll figure it out in a little bit. C, we can actually use 38 if you wanted to, but usually you want to use one closer to the y-axis where you're using cosine. Use the peak. We could either use this one or this one. So we're going to use the 10. 10 to the right. The midline, D, is 8. And all I need now is the B. The B, if in degree mode, is 360 divided by the period. I can get the period one of two ways. I can either say 38 minus 10, which is 28. Or you could have said, well, 7 degrees is a quarter. 7 degrees times 4 to make a whole cycle. And look, you get 28 again. So it doesn't matter the logic, guys. As long as you're using sound logic, you should be fine. So 360 divided by 28. I don't think that's going to go in there pretty. So I'm going to take my calculator. And I'm going to go and I'm going to type in 360 divided by 28. And then I'm going to tell my calculator to give me a fraction. 360 divided by 28. I get this long decimal. It goes on forever. Just tell the calculator, guys. Math, frac, enter. And there it is, 90 over 7. 90 over 7. All right, here's my equation. Y equals 5, 90 over 7 here. Cosine, open parenthesis, 90 over 7, open parenthesis again. X minus 10 degrees, close, close, plus 8. I'm going to type it in my calculator, and I'm going to check if I got the same thing as this. Really, I'm just going to check these two right here, or I guess 3. So take a calculator. Y equals, clear, clear, 5 cosine, 90 over 7, open parenthesis, x minus 10, close, close, plus 8. 8 here. I'm not going to push graph yet. I'm going to push window. And all I care about is this window. So I'm going to go 0 to like 40 for x. 0 to 40. X scale by 1. Yeah, that's fine. Y min. I'm going to go 0 to 15. 0 to 15. Y scale by 1. X res, leave it alone. Delta x, leave it alone. Trace step, leave it alone. Graph. See? I'm going to push trace. X scale means like you see these little grids down here. Every one of the spacing is 1. If you would have put 5, you would have seen it by 5, or every little hash mark or whatever you want to call it. Trace. I'm gonna push 10, and let's see if I have a peak at 10. 10. Enter. Yep, there's my peak. 13. I'm gonna push 17. At 17, I better be at 8. 17. 1 7. Yep, there I am at 8. I'm going to do one more. I'm going to do 24. At 24, I better be a minimum. 24, enter. And there it is, 3. Do you guys see what we did? Was the explanation clear? Have you guys ever done this before with sinusoids? Oh, look at you guys winning at life. Go call your buddies. Do you guys have buddies at other high schools? Call them later on tonight and see what they're doing. As a matter of fact, when you do your homework, maybe put it on Insta and put hashtag MathLive, get on my level, and then put like, if you're not on my level, don't talk to me. And then I'll reduce like the DMs that you're getting. Yeah. Or, or whatever. I don't care. All right. There it is, guys. Let me give you your assignment.